In Chapter 18, attention helps us to search a cluttered world for specific patterns. It says that we use attention to help systematically scan the world in order to find some specific items in a sea of distractors. If an item is different from the distractors in a fundamental way, it is easy and the target will immediately pop out. Feature search is a search for an item in which the target pops out right away because it possesses a unique attribute. Conjunction search is a search for an item that is based on two or more features, example, size and color, that together distinguish the target from the distractors that may share some of the same attributes. Results from many experiments suggest that in conjunction searches we are coordinating multiple cognitive feature maps. Feature maps are overlapping maps of the searched array, with each map focused on one particular stimulus attribute, color, shape, and so on. The feature integration theory is the idea that conjunction searches involve multiple cognitive feature maps, overlapping representations of the search array based on individual stimulus attributes. It helps us address the binding problem. The binding problem is the question of how the brain understands which individual attributes blend together into a single object when these different features are processed by different regions in the brain. According to the feature integration theory, simple pre-attentive stimulus attributes guide our scanning of the environment, with higher order processes coordinating the binding of features and ultimately conscious perception and selection. This could be why conjunction searches run much faster when you direct your attention to a single basic attribute of the stimuli to be scanned rather than using systematic voluntary steering of the attentional spotlight using all attributes simultaneously. A bottom-up process is a process in which lower-order mechanisms like sensory inputs trigger additional processing by higher-order systems. There may be no conscious awareness until late in the process. The top-down process is a process in which higher-order cognitive processes control lower-order systems, often reflecting conscious control. Consequences of attention in the brain is asking how selective attention modifies brain activity to enhance processing of stimuli. Mechanisms of attention are the brain regions that produce and control attention, shifting it between different stimuli and different sensory modalities. Temporal resolution is the ability of an imaging technique to track changes in brain over time. Spatial resolution is the ability to observe the detailed structure of the brain. Electrophysiological approaches offer the speed, temporal resolution, necessary to distinguish the consequences of attention from the mechanisms that direct it, and brain imaging techniques like fMRI offer the anatomical detail or spatial resolution to figure out exactly where these neural actions are taking place. In attention affects the functioning of the brain, an event-related potential, or ERP, is the average EEG recordings measuring brain responses to repeated presentations of a stimulus. It reveals regional changes in the brain activity much faster than brain imaging techniques like fMRI. In distinctive patterns of brain electrical activity marked shifts of attention, it defines the N1 effect as a negative reflection of the event-related potential occurring about 100 milliseconds after stimulus presentation that is enhanced for selectively attended input compared with ignored input. The P3 effect is a positive deflection of the event-related potential occurring about 300 to 500 milliseconds after stimulus presentation that is associated with higher-order auditory stimulus processing and late attentional selection. And normal P3 responses are a reliable finding in people with schizophrenia, consistent with their difficulty filtering out distracting information. Attention to visual stimuli is likewise reflected in ERPs, but because the neural systems involved in visual perception are different from those involved in audition, endogenous visual attention causes its own different distinctive changes in ERP. The P1 effect is a positive deflection of the event-related potential occurring 70 to 100 milliseconds after stimulus presentation that is enhanced for selectively attended visual input compared with ignored input. The visual P1 effect is an increase in an amplitude of the P1 component of event-related potentials that occurs for stimuli that are the focus of attention. ERPs during visual search tasks when we are directing attention so as to find a particular target in an array and ignore distractors. This is a characteristic enhancement of some component, and N2 is triggered at occipitotemporal sites contralateral to the visual search stimulus to which attention is being directed. Extensive experience with action video games, which rely heavily on visual attention, is associated with neural changes and lasting enhancements of longer latency ERP components. This often comes with impairments in social and emotional processing. Training with video games even enhances cognitive control, the ability to multitask in older adults, indicating that plasticity and attentional control systems is probably retained through life. Neuroimaging confirms that the anatomical foci of attention show augmented processing. It says that PET and fMRI studies have confirmed that a general consequence of attention is an enhancement of the activity of the brain regions that process key aspects of the target stimuli. In a study, participants completed a spatial cueing test by both fMRI and ERP data was collected. ERP was used to decide when to collect fMRI images. Researchers were able to find anatomically distinct regions of enhanced activity in a visual cortex that corresponds to the spatial locations to which participants directed their covert attention. An effective neural activation may even be observed in subcortical visual structures. Using a sustained attention test, the researchers found fMRI enhancements in the superior colliculi and lateral geniculate nucleus. During later stages of the visual systems, physiological effects of attention become even more pronounced.